Okay, I'm going to apologize ahead of time. I forgot that I was going to make a video on wood stabilization before I got my scales half finished, but I'm going to use this popsicle stick to represent a scale for the first part. So, wood stabilization, what is it? Why should you do it? Well, wood stabilization does exactly what the name implies. It stabilizes your wood, but it also hardens it quite a bit. The stabilization stops it from shrinking. If you've ever looked at an old fence, old house, window frame, anything, you'll know wood shrinks with time. Uh, Hardens. You ever split a wooden scale that you've made, and anybody that's ever made a wooden scale, unless you're really, really lucky or really, really good, you've split one or you're a liar. Um, yeah, so this is how to help prevent splitting them and how to make them last forever. This here popsicle stick, when I'm done with it, it's going to be a lot harder and it'll last forever. So what you want to do is you want to shape and sand your scale to just about as thin as you're going to have it when you're finished product. You can be a little thicker, but the thinner the better. That way it's going to be easier to get the product into your wood. There are many products that you can buy. There's cactus juice, there's pentacryl, there is Minwax makes one. Sometimes they're marketed as wood hardener, sometimes as wood stabilizer. Me, I make my own. All I do is I throw plexiglass and acetone. I mix them together because if you look on the label of wood stabilizer hardener, those are the two main ingredients. You can also buy two-part epoxy and thin it down with acetone. It's an expensive way to go, but it can be done. I mean, if you're only doing one or two scales in your lifetime, that's another way to go. But acetone and plexiglass works good. If you look in here, I've got some white crap in there. You'll see little blocks of stuff. What that is, it's some Lexan polycarbonate I threw in there thinking it was plexiglass. Doesn't hurt anything to be in there. It's just going to sit there and do nothing because it doesn't melt. So that's just, you got to make sure it's actually plexiglass. What it's doing in there now is just taking up space, so I don't quite need as much stuff to fill my jar. So I don't need quite the volume. I don't really have a magic number for you, like so much acetone to so much plexiglass, but what you want is fairly, you don't want it too thick or it won't absorb, and it doesn't take too much. And you can actually use this as a finish when you're done. You can paint it on just like you would varnish or shellac. While you're working with it, you'll know it dries incredibly fast. And goes on thick. You can thin it out as thin as you like so that it goes on smoother and faster. Pretty sure you could spray it on with an airbrush if you have such an animal. You can dip it, then sand it out and finish it afterwards. It's it makes it pretty hard afterwards. So on to what I do. I've made this contraption. It's I've put a fitting through an old canning jar. I use the kind that you can change the rubber seals on. This isn't the lid that, this is the kind that has the seal already built into it. I just go ahead and buy these replaceable seals. I put a little skim of Vaseline around here and here. I've just put some tape around all my joints. Hose clamps probably do the trick. Just because I didn't want to bring my whole setup into the house. Sorry about the mess on my bench. Here I have it going straight to a brake bleeding vacuum pump. What I would normally do is run this pump into an empty setup, just exactly the same as this, and maybe even a little bigger jar. My other one is bigger, so that you're pumping empty air instead of acetone vapors, which, acetone, it's a little bit harsh on the seals. It's never hurt this, but over time it might. So that's just a thought. If you want to want to do it that way, you can, or you can do it this way. Also, for vacuum, you can use, I've got a thing for drawing fluid out of a, like drawing oil and fluid out of a engine. You can use those. You need like a shut off valve in here, so you suck, you pull on it, you get some suction, and then you shut it off and reset. It's a little bit hokey, but it does work. Any way you want to get suction into this. This is nice because it does have a valve and it tells you. Okay, so I'm going to open this up and throw the wood into it. So I'm one-handed here, so sorry about the shakiness. Here, I'm going to set you down. Okay, now I've gone ahead and thrown it in. Gave it a few pumps and then stopped, so I've only got it right up to, sorry, get you in focus there. 10 pounds of mercury there. You're only going to get it up to about 20 pounds of mercury. You'll notice it's going to start drawing air out of it when it hits about 18, and then because of acetone starts to boil about 15 pounds of mercury. So the change in atmosphere, the acetone will actually start to boil. So it's not going to do you much good to try to get it much below 15 or 20, because it's just going to keep bleeding back to 15. So, you know, pump it up to 20. It's going to bleed back. You know, you might have to pump it up a few times. Sometimes you got to fiddle with keeping seal. That's always fun. But I'll show you what I mean by boiling. You'll notice bubbles will start to come up when you get. Okay, they're already starting. The white stuff is, you know, that's air coming out of the wood. But when you get around 20, you'll notice it's really going to start to go crazy. And that's the acetone actually starting to boil. You know, just like water boils at a lower temperature at higher atmospheres, because the atmospheric pressure is lower. Well, same thing with acetone, only it's you know, lower atmospheric pressure. It's boiling. You know. I'm not exactly Bill Nye the Science Guy, so I'm probably not explaining it very well. So yeah, so it's okay, let me set that aside. So you see, now this is just a popsicle stick, and I've just got it setting in there. But obviously, if this was an actual scale, I would have it weighted down somehow. A lot of times what I'll do is I'll have a, I'll have a piece of metal through my hole where I'm going to peen it, and I'll have it weighted down. It just makes it easier to pull out so your fingers don't get covered in the stuff. And again, it is fairly loose. Got to be loose. It is fairly thin. You don't want to bleed it up through your hose and into your pump, so I'm trying not to shake it too much. But again, you do want it fully submerged. You could probably get it away without the vacuum. You just might have to soak it for, you know, instead of a day or two, you might have to soak it for 3-4 days. That's all. The length of time I soak it for is until until it doesn't want to float. And this popsicle stick is one, I've got it jammed in there. But when I take it out and I let that popsicle stick go and it just drops straight down without wanting to float at all, is when I know it's absorbed all I want it to. And because that is so thin and so such a porous wood, it's probably got a lot in it already with the vacuum. Okay, actually I haven't lost much vacuum yet. So yeah, so this is the vacuum portion. Now you'll notice when you pull it out at the end of your vacuum, it's going to be quite plasticky looking. But a lot of that sands off, and it'll look as much like natural wood as you want it to. Now you can see what I'm talking about, the vapors coming up. That's just gas vapor, because you can see how much space I've got in there. And that's why I've got the secondary empty tank in my shop that I use. Okay. All right. I'm going to get back to you with my proper scales in the next segment that I made using my proper videos. But I hope you get the idea using my popsicle stick. And I'm sorry that I forgot about you guys when I was beginning this video. Okay, I just pulled my scales out of my solution after 2 days. You know, it's time to pull them out when they stop floating. And I don't know if you've been watching, but in the 20 seconds I've been filming, this little spot here dried. That's how fast that acetone evaporates. You'll notice your scales will be noticeably heavier than when you put them in. They're going to be harder. So I'll flip this over. They're going to look darker. The color comes back. The color does come back. Sorry about the shakiness. You're probably all dizzy now. The color does come back to a natural wood. Pretty sure you can even put tint in it if you would like. What you can do also is cut a bunch of blanks. Just cut a bunch of, well, whatever shape you want, really. I would go for, you know, 2x5, sorry, 2x6 probably, pieces of wood, whatever thickness you'd like, say 3.5 millimeters. Just have them sitting in your solution and pull them out as needed. Then you've always got some wooden scales ready to make. Isn't that nice? Just a thought. I know knife makers do it. Still might need to thin these out. I know I'm going to need to round them on the corner. And like I say, they've been out for less than a minute, and they're already, they're not tacky, but you know, they do dry fast. If I was to sand them, it might gum up my sandpaper a little bit. Yeah, that spot there on my rock is slightly tacky. So if you look at my fingers, it's like I've been painted my fingers with shellac now. That's how it comes out. But now it's all soaked into my wood. It's almost like there's a plastic texture to my wood now. But like I say, when I sand it out, it does give it back its natural wood look with the strength of plexiglass inside it. A lot less likely to shatter in that. So hopefully I can edit this all into a movie that's going to make some sense. A movie. No, it's not going to be a movie. It's going to be a video clip that will hopefully teach somebody something that they don't already know. Still a wee bit thick, I think.